Good afternoon. On today's Angry Bulletin. Finally, after numerous media stories to the contrary, it has been definitively proven that Oumuamua was neither an asteroid nor a comet. A recent paper released by an astronomer who is not Avi Loeb has conclusively demonstrated that the hydrogen outgassing model that so many astronomers have been clinging to explain Oumuamua's bizarre and unnatural behavior is simply impossible. So what is Oumuamua? All of this and more coming at you on the Angry Astronaut right now. Good afternoon, and once again, welcome to the Angry Astronaut. We are going to be bringing you a triple shot of alien content for the holidays. Yesterday, we had a brief episode, an angry clip, I guess would be the best way to describe that one, about a UFO that was spotted in Minnesota that continues to confound researchers. Today, we're going to be talking about Oumuamua. And then tomorrow, by popular demand, we're going to be talking about alien superweapons that we may or may not have observed in operation throughout the cosmos. And I'm not joking about that, but we're not going to get into that in this episode. We're going to talk about Oumuamua. So one thing that really annoys the hell out of me about Oumuamua, I mean, I'm called the Angry Astronaut, and I want to be very clear as to one of the things that makes me angrier than anything else is how the media continues to cling to debunked theories about phenomena that may have an artificial extraterrestrial origin, and then a natural explanation comes out, and that natural explanation is subsequently debunked a few months later, but the media continues to cling to that rational, mundane, natural explanation because, after all, that's the responsible thing to do, isn't it? If you keep talking about aliens, you're a bunch of nut jobs, and you definitely don't deserve to be called a legitimate news agency. And Oumuamua is one of the worst examples of this. For example, the media continues to picture Oumuamua as looking something like this. Now, even astronomers admit, the most mainstream conservative astronomers admit, that this is not what Oumuamua looks like. This is entirely too thick of an object. It's elongated, that's about right, but it's not reflective enough, it doesn't have a high enough albedo, and it's not nearly flat enough. That's one thing that's very strange about Oumuamua, is its shape. This is actually a better idea of what Oumuamua might look like if it were an asteroid. But the thing of it is, it's not an asteroid. We know that for certain now, in spite of the fact that at the beginning of this year, another scientific study came out claiming or trying to put forward a theory, a very implausible theory, as to how hydrogen could have caused the observed acceleration of Oumuamua as it left our solar system. And now that particular theory has been completely debunked by another scientific paper that was not written by Dr. Avi Loeb. It's actually written by an astronomer who does not believe that Oumuamua is an artificial object. He has some other ideas as to what he thinks it might be, although these are equally implausible, and he actually admits that this is a very unusual object, an object that really defies all natural explanation in many ways. It's just so strange. There are so many odd things about this object, and yet the media continues to claim to the mundane, the natural explanations that have been debunked now for months, because that's the responsible thing to do. That's the comfortable thing to do. That's the thing that makes us feel safe, makes us feel secure, is the knowledge that there are no technologically superior alien civilizations lurking out there that might show up on our doorsteps intending to mean us harm someday. We don't want to believe something as frightening as that, so we choose not to, and the media embraces that school of thought. So what does Oumuamua actually look like? Well, this rendering created by Nick Henning, a fantastic digital artist. You may have seen a lot of his work online in the past, does some great work, and he created this image for me. But why do I think it looks like this? Of all the configurations of an alien ship, why do I believe that Oumuamua looks like this bizarre object? First of all, a quick review of all the unnatural things about Oumuamua. First of all, where did this object come from? Well, as near as we can tell, based on its trajectory before it encountered the sun, Oumuamua was moving through the galaxy at a speed that corresponded to what is called the galactic standard of rest, meaning that it was stationary in relation to the stars moving around it. It was rotating at precisely the same speed as the rate of rotation that the galaxy has in general. That makes it extremely useful for a navigational buoy for starships traveling between the stars who need a fixed point in space to lock onto. Now, this could have happened by chance, but the odds of it happening by chance are 0.2% or 500 to 1. That's the first strange thing about this object. Number two, it was rotating at a very consistent and unchanging speed. This also is not unusual for an asteroid, a comet, or some other object in space. However, as you will see later on, the fact that Oumuamua continued to rotate even when it was accelerating out of the solar system is an extremely unnatural thing for it to do. Also, Oumuamua was highly reflective, an extremely high albedo, unnaturally so for an asteroid or a comet. Now, of course, comets are pretty reflective because they're comprised primarily of ice, but Oumuamua was substantially more reflective than even the average comet, looking more metallic than ice-like. Nevertheless, there are objects in the solar system that are about as reflective as Oumuamua, so that's not necessarily that unusual. Also, its length compared to its width and its thickness is highly unusual. At best, Oumuamua is a flat pancake-like object. Once again, if comprised of hydrogen and ice and perhaps nitrogen, that sort of thing, as many astronomers have theorized that it's comprised out of in order to back up their explanations as to how Oumuamua accelerated out of the solar system without any visible means of doing so. Well, how the hell did something this thin and with this low of a boiling point survive a close encounter with the sun? Oh yeah, and that's something else we need to cover. The fact that Oumuamua passed through the solar system on the trajectory that it did. Keep in mind, Oumuamua could have passed through the solar system at any point, theoretically. All of this was purely by chance, and yet it passed so close to the sun, within the orbit of Mercury. Again, a very unusual thing for it to do, and on its way out, it was less than 0.2 of an astronomical unit away from Earth. Closer to Earth than any planet in the solar system gets, even at its closest approach. And here's the strangest detail of all, as I have alluded to throughout this video. On its way out of the solar system, Oumuamua began to accelerate non-gravitationally with no visible means of propulsion. Now, comets commonly change their trajectories and velocities because of cometary outgassing, as ice is converted into a gas by the sun's heat and outgasses, as we have seen with a comet that's recently been passing through our solar system this year. However, Oumuamua demonstrated no visible outgassing whatsoever. We had some of the most advanced telescopes on the planet trained on it the entire time, and we saw no evidence whatsoever of any cometary outgassing. Not only that, remember I talked about the rotation before? Well, any cometary outgassing, especially that caused this big of a change in velocity, should have changed the rotational speed of the object. It should have modified it to some degree, and yet it didn't. Oumuamua continued to rotate at the same speed, the same rate, unchanged in spite of its strange acceleration. All of these things are completely unnatural. And yet, at the beginning of this year, a paper was released by a pair of astronomers who argued that a cometary object, when subjected to galactic cosmic rays for 100 million years, would produce enough molecular hydrogen freed from water ice, that is to say, hydrogen on its own over the course of 100 million years of galactic cosmic ray bombardment, whereby when the object actually passed through the solar system and in close proximity to the sun, that molecular hydrogen was released and produced the observed acceleration. We couldn't see the hydrogen being released because our instruments were not designed to pick up hydrogen on its own. There were many problems with this theory. First of all, they didn't explain why the rotation didn't change in spite of this massive outrush of hydrogen. We're talking a lot of hydrogen in order to be able to produce the observed acceleration. On top of that, any sort of outgassing of that magnitude should have also carried a fair amount of the object with it. In other words, there should have been debris traveling out of Oumuamua in addition to the hydrogen. No such debris was observed. They didn't explain that either. Dr. Avi Loeb brought up these problems in a paper of his own. However, the media completely ignored Dr. Loeb and proclaimed this new theory as the valid explanation as to what Oumuamua actually was, because after all, Dr. Loeb is a nutjob who believes in aliens. However, on November 29th of this year, another paper was released by Niels Ligertink, who's a physical chemist who studies the behavior of various elements in space. He crunched a lot of numbers, the same types of numbers that the original astronomers did, and discovered that even after 100 million years, cosmic ray bombardment of Oumuamua would not have produced enough molecular hydrogen to produce the observed acceleration. Indeed, even after 500 million years, the numbers simply don't add up. For one thing, the object loses molecular hydrogen even in interstellar space, almost as fast as it is produced. On top of that, cosmic rays don't pierce that deep into an object, especially an object made out of ice. Therefore, only the upper layers would have been converted into molecular hydrogen, and that simply would not have produced enough molecular hydrogen in an object the size of Oumuamua. He crunched the numbers over and over again and discovered that even after billions of years, most probably, enough molecular hydrogen would not have been created by this process to produce the observed acceleration. Now, of course, that doesn't mean that he thinks that Oumuamua is an alien object. Rather, he thinks that it's an object that's comprised out of a highly complex collection of chemicals, perhaps a fragment of a piece of a planet of some kind. A planet similar to Pluto with a lot of nitrogen in it, and perhaps it was nitrogen outgassing that created the acceleration. Although the notion of a nitrogen iceberg was debunked years ago, so it would have to be something comprised of a unique collection of chemicals. Very strange, though, that an outgassing of this collection of chemicals would only produce acceleration with invisible gases and not with some sort of gas that we could detect. Very interesting and fortunate coincidence indeed that something like that would happen, and also not impact the rotation of the object in the process. The fact of the matter is, all natural explanations for Oumuamua continue to fall flat, and yet the media continues to not acknowledge this fact. So what was Oumuamua? What you're looking at right now is what the Earth looked like from Oumuamua's perspective as it was making its way through the solar system. And as you can see, it ended up passing a pretty damn close to our planet. Not insanely close, of course. We're talking still over 10 million miles away, but definitely close enough to get a good look at us, and perhaps close enough to dispatch a probe of some kind. So let's have a look at our depiction of Oumuamua. Oumuamua looks more like a concave seashell than a pancake. It is a light sail, a few millimeters thick. and Avi Loeb, along with one of his associates, crunched some numbers to determine how thin would Oumuamua have to be in order for solar radiation alone to push an object as big as Oumuamua out of the solar system at the observed speed. And it turned out to be a few millimeters thick, which exactly corresponds to the thickness of a light sail. However, Oumuamua does not have the albedo of a modern-day light sail, indicating that it has sustained damage over time, which again makes sense, especially if it's been in interstellar space for thousands or millions of years. In addition to that, Oumuamua traveled strangely close to our planet, traveling conveniently right through the Goldilocks zone of our star, and at the same time, an object also from an interstellar destination, approximately 1 meter in diameter, pierced our atmosphere in 2017 from a trajectory similar to what Oumuamua's trajectory was and hit the ocean off the coast of Portugal. Did Oumuamua target a promising-looking planet in the Goldilocks zone of our star and dispatch one or perhaps a number of spherical probes to check us out? Might we be seeing some of those spherical probes in our atmosphere today? Of course, all of this is speculation, but this is a theory I'd like to put forward. Oumuamua is a buoy of some kind, a marker buoy, a navigational aid of some kind, and it rotates at a specific speed so that anybody observing it can identify it easily. Granted, you would need incredibly advanced optical equipment to be able to see an object like Oumuamua blinking against the stellar background. However, we're talking about an alien species many thousands of years or perhaps millions of years more advanced than us, so I wouldn't put it past their capabilities to be able to see Oumuamua and use it as a navigational beacon. By chance, it happened to encounter our star, and when it did so, it was pulled in by the sun's gravitational influence. It maneuvered itself to pass ideally through the Goldilocks zone of our star to make a close approach to any planet that might look promising, because this is its secondary objective, to dispatch a probe or perhaps a series of probes to any planet that might look promising in the Goldilocks zone of any star it might encounter. And then on its way out of the solar system, it adjusted its light sail slightly to catch some solar radiation to give it a little bit of a bump on the way out, perhaps simply as a course correctional maneuver in order to eventually bring the object back on station so that Oumuamua might reposition itself at the galactic standard of rest as it was programmed to do. Of course, this vehicle would be struggling at this point, having traveled between stars for many thousands or perhaps millions of years. Its light sail isn't in the greatest of shape, but nevertheless, it's still functional, at least at a basic level of functionality to carry out its primary tasks, and it's heading on its way out of the solar system after a brief chance encounter with a planet that might or might not have an advanced civilization on it, and now it's on its way out of the solar system to continue its long, interminable journey. Oumuamua is more of a galactic wanderer than an extraterrestrial explorer, at least as far as I think. And again, this is just a theory, but nobody else really gets an opportunity to come up with these theories. No serious scientist would dare postulate some sort of theory of their own as to what Oumuamua might be, at least not an artificial explanation, for fear of destroying their credibility. And that's the sort of thing that makes me the angriest of all. By the way, this particular illustration is now on t-shirts and sweatshirts, posters, all sorts of cool stuff in my Angry store. And if you order your merch before the end of the year utilizing this promo code ANGRY23, you will get a 10% discount on your Oumuamua merch. So display your belief in an artificial explanation for Oumuamua. Don't forget to like and subscribe, and until the media stops depicting Oumuamua as a giant interstellar cat turd, I urge all of you to stay angry about space.